is about trigonometric equations. Show that the equation cotangent squared theta plus 2 cos 2 theta equals 4 can be written in the form 4 sine to the fourth theta plus 3 sine squared theta minus 1 equals 0. So first of all, cotangent is 1 over tangent, and in the MF19 we have this formula. So 1 over tangent is the reciprocal cos over sine. And for the cos 2 theta, because here we don't have 2 theta in the angle, we have theta only, we have to use the double angle rule. So for the double angle rule, we use cos 2a equals 1 minus 2 sine squared. So in case you are wondering why don't we use this part, or why don't we use this one here, well, because yeah, we need to get what we need to prove here, and this is in sine, this is in sine, so there is no cos at all. If we use this, we're gonna have something in cos, something in cos, so we have to use this form of the MF19 formula. So cotangent squared is cos squared over sine squared, and cos 2 theta is 1 minus 2 sine squared theta, and we now distribute the 2, and we can multiply both sides by sine squared. So actually we multiply both sides by sine squared theta here. So we multiply by sine squared theta, and after we multiply sine squared times this, you cancel out, we get cos squared, sine squared times 2 sine squared, so 2 sine squared times 1, 2 sine squared, 2 sine squared times minus 2 sine squared, minus 4 sine to the fourth. So after we expand everything, we get something without fractions anymore. Now we can simplify. We have for the cos squared, we still have to use the Pythagorean here because everything should be in sine. So if you just subtract both sides by sine squared, you get cos squared equals 1 minus sine squared. So we replace the cos squared with 1 minus sine squared. Now everything is in sine. We can simplify. Start with the highest power, minus 4 sine to the fourth, and for the sine squared we have, this is minus 1 plus 2, so it's just 1, but we still have 4 from the right, so we move it to the left. We subtract both sides by 4 sine squared theta, we get minus 3 sine squared theta, and we still have plus 1. And then we multiply throughout by minus, so we have what we need to prove. Now for the second part. Hence solve the equation cotangent squared theta plus 2 cos 2 theta equals 4. And if you look at the previous question, it says we have this, which is exactly the same. Make sure it's exactly the same. So that means what we are solving is actually this equation. Now to solve this equation, if it's confusing, let's just use sine squared equals x. So this is sine squared squared, so this is x squared, this is x. We have a quadratic, and then use the quadratic formula, minus b plus minus b squared minus 4ac all over 2a. This is the b, this is the a, this is the c. Use a calculator, we get minus 1 and 1/4. So now sine squared can be minus 1 or 1/4. If sine squared is minus 1, after you take the square root of both sides, you get sine theta equals the square root of minus 1, which is imaginary, so this is rejected because we don't use complex numbers here. We don't use imaginary numbers. Now for this, after you take the square root of both sides, you get plus minus 1/2. So for the base angle, we use inverse trigonometry. In this case, we use inverse sine, and we use the positive value. So we don't use negative, we have to use something positive to get the base angle in the first quadrant. Use a calculator, you get 30 degrees. Now if you look at the domain here, it says the domain is 0 to 360 degrees. So Theta is between 0 and 360 degrees, and the value of sine theta is positive or negative, which means we can use all the quadrants 1 to 4. For quadrant 1, it's just the base angle 3 degrees. For quadrant 2, we have to use 180 degrees minus base angle. For quadrant 3, 180 plus base angle. Quadrant 4, 360 minus base angle. So the answer is therefore quadrant 1, quadrant 2, quadrant 3, quadrant 4, which means we have 4 solutions. Alright, I'll see you again next time.